Alright guys, now we're going to do section 7.5a, apply properties of logarithms. The first thing we're going to do is just look at what our properties of logarithms are. Now, when we were doing properties of exponents, addition and multiplication kind of went together, and subtraction and division kind of went together. Same type of thing with product property. If I have log base b of m times n, that is the same as log base b of m plus log base b of n. So in other words, my x values, or my multiplication and my addition, work together and switch back and forth. Same thing with quotient property. If I have log base b of m divided by n, it is the same as log base b of m minus log base b of n. So again, we can switch back and forth between division and subtraction. Now, our last one is going to be our power property. A power property just means that if I have log base b of m to the n, I can take this n and I can move it to the front. So I have n log of base b to the m power. Now, the only thing we're going to do in these next few examples is expand. So I'm not going to be solving for anything. I'm not going to be doing anything besides making this or using these properties for these equations. So I have log base 4 of 5 times 6. So I'm just going to split this and make it log base 4 of 5 plus log base 4 of 6. And that's it. That's all you do to expand. Now the next one, we're going to do the exact same thing, except this one is division. So I'm going to use subtraction. So I'm going to have log base 3 of 4 minus log base 3 of 3. Now, we do know log base 3 of 3, so we can leave log base 3 of 4 minus 1, and then we are good. Now, the last one I'm going to have you somewhat simplify. So I have log base 8 of 2 to the 4th power. So I'm going to take this 4 and I'm going to put it in front. So now I have 4 log base 8 of 2. Now I want you to look at the log base 8 of 2. And let's try to simplify this. So I'm going to write it off to the side. So this rewritten as an exponential is 8 to the x is equal to 2. Now, what I notice is that I'm going down. So I'm going from 8 down to 2. So that means I'm going to have some sort of fraction exponent because I'm going to have to root. So if I take the cube root of 8, then I get 2. So my x value is going to equal 1/3 because cube root of 8 is the same as 8 to the 1/3 power. So x is equal to 1/3. So now over here I have 4 times 1/3, which is equal to 4/3, and that is my solution. Okay, now we're going to move on and do some more expanding. Now these ones require a few more steps. So the first thing I'm going to do is I see that I have a multiplication problem. So I can see that it is log of 3 times x to the 4th. There's an imaginary multiplication sign there. So what I'm first going to do is use product property. And now using the product property, then that means I'm going to have log of 3 plus log of x to the 4th. Now remember I have an imaginary base 10 here. So there's an imaginary base 10 here, an imaginary base 10 here. Now I have an exponent here, so now I can use the power property. And what I'm going to do is I'm going to take this 4 and I'm going to put it in front. So I'm going to end up with log of 3 plus 4 log of x, and this is going to be my answer to expand. Now the next one is even more tricky because we have quotient property, product property, and power property all working at the same time. Now the first thing I'm going to do is use quotient property because I want to get rid of my division sign. So I have quotient property . which means I'm dividing, so I'm going to subtract my stuff. So I have log base 7 of 3x squared minus log base 7 of 5y cubed. So I split this into subtraction. Now I'm going to take the product property of these pieces here, this piece and this piece. So I have product property. Now when I'm multiplying, I'm going to have to add. So that means I'm going to have log base 7 of 3 plus log base 7 of x squared minus this whole thing, log base 7 of 5 plus log base 7 of y cubed. Now, I could distribute this negative to make it log base 7 of 3 plus log base 7 of x squared minus log base 7 of 5 minus log base 7 of y cubed. So now that I have that, I'm going to use my power property for this piece and this piece. So, power property. So I have log base 7 of 3, nothing changes there. My squared is going to come to the front. So now I'm going to have plus 2 log base 7 of x minus, this one's not changing, it's going to stay log base 7 of 5. And then my 3 is also going to come to the front. So I'm going to have minus 3 log 7 of y. And this here is going to be my final answer. Now I know it looks pretty confusing, but if you know your properties, this is actually pretty simple and you should be okay. Now the last one. We're going to do the same type of thing. We are going to do quotient property first. So doing quotient property, then I'm going to have log base 6 of 5x cubed minus log base 6 of y. Now I have product property here, so I'm going to split that up. So I have log base 6 of 5, and since it's product, I'm going to add log base 6 of x cubed minus log base 6 of y. And then the last thing I'm going to do is product property of this piece. So this piece is going to stay the same. So I have log base 6 of 5 plus, now my 3 is going to come to the front. So I have 3 log base 6 of x minus log base 6 of y. Okay. Now the next thing is we are going to use these to solve. So I'm going to have log base 3 of 6. Now the thing that I can do is I can split or make this log base 3 of 2 times 3, because 2 times 3 is equal to 6. Then I can change this and make it log base 3 of 2 plus log base 3 of 3. Now they told me log base 2 of 2, or 3 of 2, which is right here. So I have 0.631. Log base 3 of 3 is just 1. So I am left with 1.631. And this is an approximate because they told me that log base 3 of 2 is approximately 0.631. Now, remember, I can't type these in my calculator because the ones that I type into my calculator have to be log base 10 of something in order for it to work. I cannot do a different base in my calculator. Now the next one. I have log base 3 of 24. So I have 12 here and I have 2 here, and luckily 12 times 2 makes 24. So I'm going to split this to log base 3 of 12 times 2. So I have log base 3 of 12 plus log base 3 of 2, and they told me both of these, so log base 3 of 12 is 2.262 2.262 plus log base 3 of 2, which is 0.631. And these added together is approximately 2.893. And the last one. I'm going to look at this one and notice that I have 32 here, and there's no way that I can multiply anything by 12 times 2 or 4 or anything to make 32. So my first idea is to reduce this or put it as a prime. So 32 goes to 8 and 4, 8 goes to 4 and 2, 4 goes to 2 and 2, and 4 also goes to 2 and 2 here. So 32 is the same as 1, 2, 3, 4, 5 2's. So I can make this log base 3 of 2 to the 5th power. Now I can use my power property and I can move this 5 to the front. So I have 5 times log base 3 of 2. Now I have log base 3 of 2, and log base 3 of 2, as we saw up here, was 0.631 approximately. So this is equal to 5 times 0.631, which is approximately 3.155. All right, I will see you tomorrow ready for work or ready for homework.